Okay, so hi everyone. Today we're going to see another problem, that is 2256 minimum average difference of LeetCode, and it's a medium level problem and it has a good like to dislike ratio. Apparently I can assume that it's a newer problem, but anyways, so let's see this problem. Now yeah. So if I talk about the difficulty, then I will say that it's easy medium level. So yeah, that was it. Now let's start with the problem. So we are given Yeah. So we are given a zero-based indexed integer array nums of length n. The average difference of the ith of the index I is the absolute difference between the average of the first I plus 1 elements of nums and the average of the last n minus I minus 1 elements. Both average should be rounded down to the nearest integer. Return the index with the minimum average difference. Okay. So what this question says is that you are given this test case, let's say 2, then you have 5, then you have 3, then you have 9, you have 5 and 3, right? And the indexes are 0, 1, 2, 3, 4 and 5. Fine. Now at this phase, I want you to, for every index, let's calculate the average difference. So what is average difference? So if I'm calculating the average difference at this point, then average of these elements and average of these elements, that is my average. And if I am talking about the left element, then the current element will be inclusive. And so this is the left average and this is the right average, right? So what will be the left average for this point? It will be 2 plus 5 divided by 2, and that is rounded integer division, right? So that is 7 by 2, so this is 3, which means at this point we will have 3 as the left average, right? And we need to take the absolute difference, which means absolute of 3 minus, now right average will be 3 plus 9 12, 12 plus 5 17, 17 plus 3 20. Now 20 is divided by how many elements are there? There are 4 elements. 20 is divided by 4, that is 5, which means the absolute difference of this thing will be 2. So the average difference is 2 for this index. Now for 0 index, the average difference will be these elements and the elements on the right, right? So this was 20 and this is 25. 25 divided by 5 is 5. So 5 from the right average, and the left average will be 2 divided by 1, which is 2. So this part is 3. So we have 3 at this part. And then you can also find the averages of these points. This will be 2, 0 and 1 and 4. So 3, 2, 2, 0, 1, 4. Very good. Now we have this average, and the minimum average that you can find is 0, right? And but you don't need to return the minimum average, the number, you need to return the index. So the minimum average, the answer will be 3, the index, right? The index at which you can find the minimum average. Now you can observe that we need sum, right? For taking average, we need, let's say I'm taking average of n elements, then I need nums of 0 all the way to nums of n, these elements divided by n, right? So I need, if I'm taking the average difference at this point, then I need these sum and the number of elements. And for this average, this will be my left average, and the right average will be the sum of all the elements. Sorry, this will be inclusive, and the sum of all the elements on the right side and the number of elements on the right side. So you can, I think it's basic, like for me that was very intuitive, that prefix sum will be used, because if we are traversing at this rate, then we are keeping a track of the elements that we had, and that will be my prefix sum. But for the elements, in order to calculate the right average, you need to have suffix sum. Now prefix sum can be maintained while traveling for the elements, while creating the average differences of 0 to n elements. But suffix sum is something which needs to be pre-processed. So we will be pre-processing the suffix sum and then having the elements. So what do I mean by that? So let's create a suffix sum. Now suffix sum will be 3, and okay, so at this point we cannot have 3, right? Because if we are at this element, then we have 0 elements on the right side, which means there will be 3 as a suffix sum. And at this element the answer will be 3, and at this element the answer will be 8. You know, we are, so at this point this is the suffix sum, right? So which is 8. And similarly at this point the answer is these elements, which is 17. And at this point the answer is 20. And at this point the answer will be 22, sorry, 25, right? I think it makes perfect sense. Now with the suffix sum array we can easily find our answer. So let's say I start from 2 and at 2 my sum is 2, so my prefix sum will be 2 and suffix sum value will be this is a suffix sum value, which is 25. So 20, and at 0 I only have one element, divide by 1 minus of, so this is basically nothing but the absolute difference. This is nothing but the absolute difference of 20 minus 1, that is the total number of, sorry, total number of elements divided by their sum, that is 2, because we only have 2, so the sum will be 2, minus of this suffix sum, that is 25. Now divide by, if I am at 0 and there are 6 number of elements, then the formula could be n minus of I minus of 1, right? Because it's a 0 based index, so we need to subtract 1, and this will be at 0 it will be 6 minus of 0 minus of 1, that is 5. And it makes sense because we have 5 elements, 1 2 3 4 5, right? So divided by 5, and this will be 2 minus of 25 divided by 5 is, sorry, 2 minus of 25 divided by 5 is 5, sorry, 5. And absolute difference of these two terms will be 3, right? Which is why we have 3 here. And same for this, that is now the first index. So the right average, you know, the right average will be equal to 2 plus 5, because initially we had 2, now prefix sum will be 5 will be added to 2, so it will be 7. And the suffix sum for this case is 20. Okay, so right average is 7 divided by the number of elements at 1 will be 2 elements, right? I plus 1. So for, let's just keep it this way. And then we have left average. Now left average is the sum of elements, that is the suffix sum on the right side. So that is 20 divided by, so we had 5 initially, but now we have moved to the other elements, which means we have decremented one element. So this will be 4 and this is equal to 5. Now 7 divided by 2 is 3. Now 3 minus 5, but we need to take the absolute difference, so that is 2, right? In fact it is minus 2, but we need to take absolute difference, so which is why it's a mod, and now we only have 2. So this will be 2. I think it makes sense. Now let's jump to the implementation, because it's not that much of a deep concept. That is why I'm not spending too much time on explaining it. If you still are not very sure of how things are working, then I think the code implementation will help you out. So first of all, we have n, that is nums.size, the number of elements. Then we have some variables. So first is the minimum difference variable, which is initialized with maximum infinity. And then we have the answer or index, let's say index, and the index value is not initialized. And yeah, so then we need something called prefix sum. So that will be a long because we have elements that could be in the range of 10 raised to the power 5. So and there are 10 raised to the power 5 total elements. So in worst case it could be 10 raised to the power 10, for which we need long data type. And this is suffix sum, and the number of elements for this is going to be equal to n, and they should be initialized with 0, right? Because this last element is not considerate of the current element, which is why it should be initialized to 0. And then I can pre-process my suffix sum. So I will start with the second last element, or I can even start with the first element, but it's better to start with the second last element, because I will have n plus I plus 1 as the index to access the previous element or the next element. And I is greater than equal to 0, I is decrementing, and suffix sum of I value is equal to suffix sum of I plus 1 plus of nums of I plus 1, which means that when I am at index 3, the sum that I am taking is the previous sum, that is 3, and the last value, that is 5, which is why this is I plus 1 and this is I, right? So I'm taking nums of I and the suffix of I plus 1. So after pre-processing it, now I can I also need another variable that is a long because it will have a prefix sum value stored in it. And yeah, so I is equal to 0. Sorry, int I is equal to 0. I is less than n, I plus plus. Now prefix sum, first of all we'll update the prefix sum, and that will be equal to nums of I. After that we need to compute or create some variables. That is, first is left average, that is one thing, and then we have right average, that is another thing. And we also need something called the average difference, right? Okay, so now first variable is left average. So left average is the sum from 0 to ith element, which means it's a prefix sum. So prefix sum divide by I plus 1th elements, because if I am on, because the 0 based index, so it will be I plus 1. And then I need right average. So right average is equal to, okay, so now in right average there's a condition. So if n minus of I minus of 1, right, if this is equal to 0, which means it's on last element, then we need not to process it, because then we'll basically dividing it by 0, and that will create an error. So if it is 0, then just return 0. Otherwise, if it is not 0, then suffix sum of I value should be divided by n minus of I minus of 1, right? And the average difference, will be equal to absolute difference of left average minus of right average. Fine. Yes, now um sorry for that. Now we have the condition. So if the min difference is smaller than, sorry, is yeah, it needs to be smaller than, yeah, if it is greater than the average difference, right, then first of all update the min difference value. Now it will be average difference, and the index value is now changed, and that is the I. After that we can simply return the index, and let's see if this will run. Okay, let's add another test case. What if we only have one element? Okay, what if the minimum element is, yes, yeah, I think it is fine. So now let's try submitting it. Yeah, it works, and it is performing very bad. I have no idea why. Yeah, we can also use a different, you use a variable, right? Makes sense, makes sense. So what we can do is, another optimization could be, in rather than using a suffix array, we can use a variable that is a long suffix sum, and that is equal to 0. But we need some pre-processing. The pre-processing will be suffix sum is added with the current index, right? Now we have this prefix sum, and suffix sum will be subtracted with the nums of I. And at this place we will be using suffix sum. Yes, let's see if this will work. Okay, so there's the thing. Let's see what is the issue now. So we are subtracting nums of I, we are excluding it. Yes, it's good. And yeah, so we should start from the last index itself rather than starting from the second last. Let's try submitting it. Okay, it also worked. And memory wise it's performing good, but time wise I don't know why it's not performing good, because the time complexity is very much equal, and the algorithm is very much equal to the best solution. So I don't know, but yeah, so this is a solution, and I think, and if you want to follow it you can, because I don't think so there's any bad thing about this solution. And if it is, and if there is any bad thing, then you can let me know in the comment section. So, and one thing more, if you want me to solve a certain problem, you can also comment in the comment section and I will try to solve it. So yeah, thanks for watching, have a good day.